AWS SysOps Exam/Certification Quick Notes 1/3 by Cloud Dev. Date, April 28, 2020. For more information on AWS, visit aws.amazon.com. Thanks to http://clusterrefract.com/notes/cert/xxxx. Updated by Mahendra Rajat. Not for circulation. What is AWS SysOps certification? AWS SysOps certification expect candidate to manage day-to-day operation, implement new setup, troubleshooting, security, monitoring, and dealing with AWS support. So you should be experienced in AWS project implementation, CloudWatch monitoring, billing, security, and troubleshooting, etc. Description. Notes and information that were collected while studying and prepping for the AWS SysOps Associate Exam. Topic. Answer. Exam time. 130 minutes. Topic. Answer. No. Questions. 65 questions. Question types. Scenario and multiple choice. Passing score. 70%. Validity period. 2 years. Renewal exam. 1/2 price off. Exam cost. $150 US. Abilities validated by the certification. Deploy, manage, and operate scalable, highly available, and fault-tolerant systems on AWS. Implement and control the flow of data to and from AWS. Select the appropriate AWS service based on compute, data, or security requirements. Identify appropriate use of AWS operational best practices. Estimate AWS usage costs and identify operational cost control mechanisms. Migrate on-premises workloads to AWS. Recommended knowledge. Understanding of the AWS tenets architecting for the cloud. Hands-on experience with the AWS CLI and SDK/API tools. Understanding of network technologies as they relate to AWS. Understanding of security concepts with hands-on experience in implementing security controls and compliance requirements. Understanding of virtualization technology. Monitoring and auditing systems experience. Knowledge of networking concepts, example DNS, TCP/IP, and firewalls. Ability to translate architectural requirements. Monitoring. Monitoring is accomplished through the usage of CloudWatch, which is a service to monitor your AWS resources as well as the applications that you run on AWS. CloudWatch monitoring can monitor EC2 instances, auto-scaling groups, ELBs, Route 53 health checks, EBS volumes, storage gateways, CloudFront, DynamoDB, Elastic nodes, RDS instances, EMR job flows, RedShift, SNS topics, SQS, OpsWorks, CloudWatch logs, estimated charges on your AWS bill, and custom metrics logs generated by your applications and services. EC2 will by default monitor your instances at 5-minute intervals. EC2 instances can monitor your instances at 1-minute intervals if the detailed monitoring option is set on the instance. By default, CloudWatch will monitor CPU, network, disk, and status checks. RAM utilization is a custom metric and must be added manually to EC2 instances in order to be tracked. 2 types of status checks. Host system status checks, physical host. Checks the underlying physical host. Checks for loss of network connectivity. Checks for loss of system power. Checks for software issues on the physical host. Checks for hardware issues on the physical host. Best way to resolve issues is to stop the instance and start it again. We'll switch physical hosts. Instance status checks. Checks the VM itself. Checks for failed system status checks. Checks for misconfigured networking or startup configs. Checks for exhausted memory. Checks for corrupted file systems. Checks for an incompatible kernel. Best way to troubleshoot is rebooting the instance or modifying the instance OS. By default, CloudWatch metrics are stored for 2 weeks. Can retrieve data that is longer than 2 weeks using the GetMetrics Statistics API endpoint, or by using third-party tools. Can retrieve data from any terminated EC2 or ELB instance for up to 2 weeks after its termination. Many default metrics for many default services are 1 minute, but it can be 3 to 5 minutes depending on the service. Custom metrics have a minimum 1-minute granularity. Alarms can be created to monitor any CloudWatch metric in your account. Alarms can include EC2, CPU, ELB, latency, or even changes on your AWS bill. Within the alarm, actions can be set, triggering things like Lambda functions, or SNS notifications if the alarm threshold is reached. Configuring custom metrics. In order to allow custom metrics to be written to CloudWatch, you must assign a CloudWatch full access role to the EC2 instance using the custom metrics. RAM utilization, for example, must be set up as a custom metric. Yum install y perl switch perl datatime perl sys syslog perl lwp protocol https /cloudwatch and ncd/cloudwatch. Look at http://awscloudwatch.s3.amazonaws.com/download/cloudwatch monitoring scripts 1.2.1.zip. Unzip CloudWatch monitoring scripts v1.2.1.zip. RMFR CloudWatch monitoring scripts v1.2.1.zip. cd AWS scripts mon. /mon put instance data.plmemutil verify verbose, dry run no data will be sent to CloudWatch. /mon put instance data.plmemutil mem used mem avail, set this up on January 5th minute cron job. Set cron job to run regularly, /5 *** ec2 user /CloudWatch /mon put instance data.plmemutil mem used. Monitoring EBS. 4 types of EBS storage. General purpose, SSD, GP2. Provisioned IOPS, SSD, IO1. Throughput optimized, HDD, ST1, and cold, HDD, SC1. Throughput optimized HDDs, ST1, and cold HDDs, SC1, both cannot be used as boot volumes. Throughput optimized HDDs, ST1, and cold HDDs, SC1, both are not available in the drop list if the volume is the root volume. Adding an additional volume will allow these option types to become present in the drop list. GP2 volumes have a base of 3 IOPS per GB of volume size. Maximum volume size is 16 TB. Maximum IOPS size of 10K IOPS total, after which you need to move to provisioned IOPS storage tier. Can burst performance on the volume up to 3K IOPS. Bursting uses IO credits. Each volume receives an initial IO credit balance of 5.4 million IO credits. This is enough to sustain the max burst performance of 3K IOPS for 30 minutes, 3K being the max IOPS available, including your standard 3 IOPS per GB. You cannot burst an additional 3K to your standard, only burst up to a max of 3K. If you need more than 3K IOPS, then you need to increase the volume size accordingly via the 3 IOPS per GB rule. When not going over provisioned IO level, bursting, you earn credits back. Don't need to know the calculation to replenish the credit balance. New volumes no longer require pre-warming, they receive their maximum performance the moment that they are available and do not require initialization/pre-warming. When restoring a volume from snapshots, the first time you access the storage block, you can see a 5 to 50% loss of IOPS due to the volume either needing to be wiped clean or instantiated from a snapshot. Performance is restored after the data is accessed once. To avoid the performance hit, volumes can be pre-warmed. For a new volume, you should write to all blocks before using the volume. For a volume that has been restored from a snapshot, you should read all blocks that have data before using the volume. Instructions for pre-warming volumes can be found here. EBS CloudWatch metrics. O volume read bytes. O volume write bytes. Provides info on the I/O operations in a specified period of time. The sum statistic reports the total number of bytes transferred during the period. The average statistic reports the average size of each I/O operation during the period. The sample count statistic reports the total number of I/O operations during the period. The minimum and maximum statistics are not relevant for this metric. Data is only reported to CloudWatch when the volume is active. If the volume is idle, no data is reported to CloudWatch. O volume read ops. O volume write ops. The total number of I/O operations in a specified period of time. To calculate the average IOPS for the period, divide the total operations in the period by the number of seconds in that period. O volume total read time. O volume total write time. The total number of seconds spent by all operations that completed in a specified period of time. If multiple requests are submitted at the same time, the total could be greater than the length of the period. O volume idle time. The total number of seconds in a specified period of time when no read or write operations were submitted. O volume queue length. N number of read and write operation requests waiting to be completed in a specified period of time. If the count is high, it would be a good indicator to up the volume size to get more IOPS available via the 3 IOPS per GB rule. O volume throughput percentage. Used with provisioned IOPS, SSD, volumes only. The percentage of IOPS delivered of the total IOPS provisioned for an EBS volume. Provisioned IOPS SSD volumes deliver within 10% of the provisioned IPS performance 99.9% of the time over a given year. During a write, if there are no other pending I/O requests in a minute, the metric value will be 100%. The volume's I/O performance may become degraded temporarily due to an action that was taken, such as creating a snapshot of a volume during peak usage, or running the volume on a non-EBS optimized instance, or accessing data on the volume for the first time, if the volume wasn't pre-warmed. volume consumed read-write ops. Used with provisioned IOPS, SSD, volumes only. The total amount of read and write operations, normalized to 256K capacity units, consumed in a specified period of time. I/O operations that are smaller than 256K each count as one consumed IOPS. I/O operations that are larger than 256K are counted in 256K capacity units. Volume queue length can come up frequently, know what it is. Volume status checks. Oh okay. I/O enabled status. Enabled, I/O enabled or I/O auto enabled. I/O performance status. Only available for provisioned IOPS, IO1, volumes. Normal, volume performance is as expected. Oh warning. I/O enabled status. Enabled, I/O enabled or I/O auto enabled. I/O performance status. Only available for provisioned IOPS, IO1, volumes. Degraded, volume performance is below expectations. Oh impaired. I/O enabled status. Enabled, I/O enabled or I/O auto enabled. Disabled, volume is offline and pending recovery, or is waiting for the user to enable I/O. I/O performance status. Only available for provisioned IOPS, IO1, volumes. Stalled, volume performance is severely impacted. Oh insufficient data. I/O enabled status. Enabled, I/O enabled or I/O auto enabled. Insufficient data. I/O performance status. Only available for provisioned IOPS, IO1, volumes. Insufficient data. Degraded, severely degraded equals warning. Stalled or not available equals impaired. If your EBS volume is attached to a current generation EC2 instance type, you can increase its size, change its volume type, or adjust its IOPS performance without detaching it. These changes can be applied to detached volumes as well. From the console, volumes console, not EC2 console, or from the API, volumes can be modified. When modifying a volume, you can monitor the progress of the modification. If the size of the volume was modified, be sure to extend the volumes file system to take advantage of the increased capacity. Monitoring RDS. Two types of monitoring. Monitor by metrics, CloudWatch monitoring. For database metrics. By database class. By database engine. Across all databases. Monitor by events, RDS monitoring. Located in Events tab. Events of everything that has happened with your instance. And set event subscriptions which work like SNS topics. Events like failovers can be a notifying event using subscriptions. Available RDS metrics. Binlog disk usage. The amount of disk space occupied by binary logs on the master. Applies to MySQL read replicas. Units, bytes. Burst balance. The percent of general purpose SSD, GP2, burst bucket IO credits available. Units, percent. CPU utilization. The percentage of CPU utilization. Units, percent. CPU credit usage, T2 instances. The number of CPU credits consumed by the instance. 1 CPU credit equals 1 vCPU running at 100% utilization for 1 minute or an equivalent combination of vCPUs, utilization, and time. Example, 1 vCPU running at 50% utilization for 2 minutes or 2 vCPUs running at 25% utilization for 2 minutes. Units, count. CPU credit balance, T2 instances. The number of CPU credits available for the instance to burst beyond its base CPU utilization. Credits are stored in the credit balance after they are earned and removed from the credit balance after they expire. Credits expire 24 hours after they are earned. CPU credit metrics are available only at a 5-minute frequency. Units, count. Database connections. The number of database connections in use. Units, count. Disk queue depth. The number of outstanding iOS, read/write requests, waiting to access the disk. Units, count. Readable memory. The amount of available random access memory. Units, bytes. Free storage space. The amount of available storage space. Units, bytes. Maximum used transaction IDs. The maximum transaction ID that has been used. Applies to PostgreSQL. Units, count. Replica lag, seconds. The amount of time a read replica DB instance lags behind the source DB instance. Applies to MySQL, MariaDB, and PostgreSQL read replicas. Units, seconds. Replication slot disk usage. The disk space used by replication slot files. Applies to PostgreSQL. Units, megabytes. Oldest replication slot lag. The lagging size of the replica lagging the most in terms of WAL data received. Applies to PostgreSQL. Units, megabytes. Transaction logs disk usage. The disk space used by transaction logs. Applies to PostgreSQL. Units, megabytes. Transaction logs generation. The size of transaction logs generated per second. Applies to PostgreSQL. Units, megabytes/second. Swap usage. The amount of swap space used on the DB instance. Units, bytes. Read IOPS. The average number of disk I/O operations per second. Units, count/second. Write IOPS. The average number of disk I/O operations per second. Units, count/second. Read latency. The average amount of time taken per disk I/O operation. Units, seconds. Write latency. The average amount of time taken per disk I/O operation. Units, seconds. Read throughput. The average number of bytes read from disk per second. Units, bytes/second. Write throughput. The average number of bytes written to disk per second. Units, bytes/second. Network receive throughput. The incoming, receive, network traffic on the DB instance, including both customer database traffic and Amazon RDS traffic used for monitoring and replication. Units, bytes/second. Network transmit throughput. The outgoing, transmit, network traffic on the DB instance, including both customer database traffic and Amazon RDS traffic used for monitoring and replication. Units, bytes/second. Have general idea of what each of the RDS metrics do. Database connections, disk queue depth, free storage space, replica lag, seconds, read IOPS, write IOPS, read latency, write latency are all important ones to know. Monitoring LB. Monitored every 60 seconds provided there is traffic. Only reports when requests are flowing through the LB. If there are no requests or data for a given metric, the metric will not be reported to CloudWatch. If there are requests flowing through the LB, LB will measure and send metrics for that LB in 60-second intervals. Available metrics. O healthy host count. The count of the number of healthy instances in each AZ. Hosts are declared healthy if they meet the threshold for the number or consecutive health checks that are successful. Hosts that have failed more health checks than the value of the unhealthy threshold are considered unhealthy. If cross-zone is enabled, the count of the number of healthy instances is calculated for all AZs. Preferred statistic, average. O unhealthy host count. The count of the number of unhealthy instances in each AZ. Hosts that have failed more health checks than the value of the unhealthy threshold are considered unhealthy. If cross-zone is enabled, the count of the number of unhealthy instances is calculated for all AZs. Instances may become unhealthy due to connectivity issues, health checks returning non-200 responses, in the case of HTTP or HTTPS health checks, or timeouts when performing the health check. Preferred statistic, average. O request count. The count of the number of completed requests that were received and routed to the back-end instances. Preferred statistic, sum. O latency. Measures the time elapsed in seconds after the request leaves the load balancer until the response is received. Preferred statistic, average. O HTTP code _ELP_4XX. The count of the number of HTTP 4XX client error codes generated by the load balancer when the listener is configured to use HTTP or HTTPS. Protocols. Client errors are generated when a request is malformed or is incomplete. Preferred statistic, sum. O HTTP code _ELP_5XX. The count of the number or HTTP 5XX server error codes generated by the load balancer when the listener is configured to use HTTP or HTTPS protocols. This metric does not include any responses generated by back-end instances. The metric is reported if there are no back-end instances that are healthy or registered to the load balancer, or if the request rate exceeds the capacity of the instances or the load balancers. Preferred statistic, sum. O HTTP code _backend _2XX. O HTTP code _backend _3XX. O HTTP code _backend _4XX. O HTTP code _backend _5XX. The count of the number of HTTP response codes generated by back-end instances. Metric does not include any response codes generated by the load balancer. The 2XX class status codes represent successful actions. The 3XX class status codes indicate that the user agent requires action. The 4XX class status code represents client errors. The 5XX class status code represents back-end server errors. Preferred statistic, sum. O back-end connection errors. The count of the number of connections that were not successfully established between the LB and the registered instances. The LB will retry when there are connection errors, so the count can exceed the request rate. Preferred statistic, sum. O search queue length. Account of the total number of requests that are pending submission to a registered instance. Preferred statistic, max. O spillover count. Account of the total number of requests that were rejected due to the queue being full. Preferred statistic, sum. Have an idea of what each metric does. Important metrics to note are surge queue length and spillover count. Monitoring Elastic consists of two different engines. OMEMC8. OREDIS. When it comes to monitoring cache engines, there are 4 monitoring points. CPU utilization. MEMC8, multi-threaded handles loads of up to 90% CPU utilization if and GT 90% CPU utilization add more nodes to the cluster. REDIS, single-threaded take 90% and / number of cores to determine scale point will not have to calculate REDIS CPU utilization in exam. swap usage. OMEMC8. Should be around 0 most of the time and should not exceed 50 megabytes. If 50 megabytes is exceeded, you should increase the memcached_connections_overhead parameter. Memcached_connections_overhead defines the amount of memory to be reserved for MEMC8 connections and other miscellaneous overhead. OREDIS. No swap usage metric, instead use reserved memory. The amount of the swap file that is used. Swap file is the amount of disk storage space reserved on disk if your computer runs out of RAM. Typically the size of the swap file equals the amount of RAM available. Evictions. MEMC8. No recommended setting. Choose a threshold based off your application. Scale up, increase the memory of existing nodes, or scale out, add more nodes, to avoid evictions. OREDIS. No recommended setting. Choose a threshold based off your application. Only scale out, add RAID replicas, to avoid evictions. Like clowns stuffed in a car, there is a finite number of empty seats that slowly fill up. Eventually the car is full and if more seats are needed, then an eviction will occur. Evictions occur when a new item is added and an old item must be removed due to lack of free space on the system. Concurrent connections. No recommended setting. Choose a threshold based off your application. If there is a large and sustained spike in the number of concurrent connections, this can either mean a large traffic spike or your application is not releasing connections efficiently. Organizations and consolidated billing. AWS Organizations is an account management service that enables you to consolidate multiple AWS accounts into an organization that you create and centrally manage. Consolidated billing. Have a single payer account. Have multiple linked accounts that all roll up to the payer account for billing purposes. Payer account is independent and cannot access resources of any linked account. Linked accounts are also independent and cannot access resources in any of the other linked accounts, or the payer account. Currently there is a limit of 20 linked accounts for consolidated billing, unless a limit increase is requested. Advantages include a single bill per AWS account, easy way to track charges and allocate costs, and volume pricing discount availability. Always enable MFA on root account, always use strong and complex passwords on the root account. Payer account should be used for billing purposes only, do not deploy resources in the payer account. When monitoring is enabled on the payer account, the billing data for all linked accounts is also included. You can still create billing alerts per individual accounts as well. CloudTrail is per AWS account and is enabled per region. CloudTrail can be aggregated into a single bucket in the payer account. Consolidated billing allows you to get volume discounts on all of your accounts. Unused reserved instances for EC2 are applied across the group. Cost optimization. 3 different instance types. Spot. Allow you to name your own price for EC2 capacity. You bid on spare EC2 instances and these will run automatically whenever your bid exceeds the current spot price. Spot price varies in real time based on supply and demand. If the spot price goes above your bid price after the instances are provisioned, the instances will be automatically terminated. Reserved instances. Provide you with up to 75% discount as compared to on-demand pricing. You are assured that your RI will always be available for the OS and AZ in which you purchased it. For applications that have steady state needs, RIS provides significant savings compared to using on-demand instances. RIs and on-demand instances perform identically. On-demand. Pay for compute capacity by the hour with no long-term commitments or upfront payments. Increase or decrease your compute capacity depending on the demands of your application and only pay the specified hourly rate for the instances that you use. EC2 always strives to have enough capacity to meet customer needs, but during high periods of high demand, it is possible that you may not be able to launch specific instance types in specific AZs. We have reached to session number 1 for study notes. See you in session number 2 of 3 series. Take care and stay safe. Thank you and bye-bye.